In this lesson, we're going to examine the idea of zeros, or solutions, a little bit further. So if you think about quadratic functions, there's three different types of situations we might have. We might have one that has two zeros, or two roots, solutions. And it could look like this. Just one example. It doesn't have to. It could look like that. It would be two roots also. It could have 1, 0, where the vertex is a 0. Or you could have a situation where you don't even have any zeros. You don't even hit the x-axis at all because your graph is above it or maybe below it or something like that. And these are kind of important situations because they tell us something about the problem that we're solving. That there is no solutions, only one solution, or you may have two solutions to worry about in two different situations. So the way we look at it kind of depends on the form of a quadratic that we have. If things are in factored form, remember factored form is the first one we started at, x minus s and x minus t. It's actually pretty easy to tell how many zeros you have because you can actually see the zeros. Remember, these are your zeros, your s and t. So if you notice that they have the same number, well, then you have one zero, the same one twice. Or if you have two different numbers, you have two zeros. And so we look at the first example here. I look at this equation and say, here's one of my zeros, 3. Here's my other one, negative 5. Oh, this has two roots. They're distinct. I can tell them apart. As opposed to this one here, where I have the same bracket squared, which we know means write out twice. Well, the 0 is negative 4 both times, so there's only one distinct root. There's one root that happens to also be the vertex. And depending on the situation, maybe these are good solutions, or they tell us something important about the problem. If things are in standard form, unfortunately, we can't just look at and tell. We have to do a simple calculation. And the thing we want to calculate is something called the discriminant. The discriminant has a formula, and the formula for it is b squared minus 4ac. Remember, a, b, and c are from standard form, okay? It turns out that if you get a discriminant that is a positive, then that means there's always going to be two roots. If your discriminant comes out to 0, there'll be a single root. And if your discriminant comes out to a negative, you can't actually calculate the roots. So there are none. Okay, so if we take a look at this next set of examples, these are all standard form equations. I'm going to calculate my discriminant. b squared minus 4ac. A, b, and c in the right order. So b squared, put in brackets, negative 4 squared minus 4 times 2 times 6. And yes, I'm worried about the number. I do want to get the right number, but I'm really more worried about is the sign. And this one happens to be a negative 32. And the fact that it's negative tells me there are no roots. This can't be solved. I couldn't try factoring and figuring out the zeros because there aren't any. If we try the next one, discriminant equals b squared minus 4. Make sure your signs are important. So negative 2 and negative 4.5. Into our calculator we go, and we get the value 0. The 0 means there's one root, and the vertex is the 0. And the third one, and I put this one there to point out something. So b squared is 7 squared minus 4 times a is 1, times c, and c is 0. There's no number over here. So if you're missing a part or a piece, that means it has to be a 0. Comes out to 49. 49 is a positive number, so that tells me there's two roots. Okay. So factor form, easy. Look at it, you can write down your answers. Standard form, you gotta do a simple little calculation first. And be careful, get the right calculation, but what you're really worried about is your sign. Okay, let's do some problem solving. So determine whether the vertex of the parabola, given here, lies above, below, or on the x-axis. So there's some things I can figure out. The first thing I want to know is, well, does it have zeros? Because if it lies on the axis, its 0 is the vertex. So I just look at that as the standard form. As soon as I see standard form, I'm thinking about zeros. I'm thinking about my discriminant. So let's make my calculation. Negative 2 squared minus 4 times 5 times 4. Okay, into my calculator that goes. I get negative 76. So I know right off the bat this has no zeros. So I know my situation is either it looks like this or it looks like this. I just don't know which one yet. But if I go back to my ideas from standard form, there are some other things I can figure out. I know that this is my a value, and I know that it's positive 5. I know positive 5 means it opens up. That tells me it has to look like this. There's no choice. It has no zeros. It opens up. That's my picture. So in that case, the vertex is above the axis. Now, I also, that's one way of doing it, I also could have actually calculated the vertex if I wanted to. We know to find a vertex in standard form, I can use negative b over 2a. That's one of our favorite formulas. So I could use my formula, 2 over 10 is 0.2, and calculate what is the actual vertex. Okay. And if I had done that, hopefully, and if you actually look at these numbers, you will notice they come out to a positive 4. So my vertex is 0.2 and 4, and obviously that, right here and right here, lies above the x-axis. So just different ways. I think the idea of discriminant and direction of opening is helpful, but if you want to go back to simple calculations, we can do that too. All right, some more problem solving. The whole idea of this is to see if a problem is solvable. If it has roots, that means it has solutions, which means it's solvable. If it doesn't, hey, stop, I can't solve it. There's no point in trying to solve it. It can't be solved. No roots. Okay. To do this, there's a couple things that have to be true. And we're going to get more into solving we started talking about yesterday and some more tomorrow. But the equation has to be equal to 0, and it has to be in standard form. If those two things are true, then it might be solvable. Let's check. So use the discriminant to determine the number of solutions each equation has. Well, before I do that, I have to see if it's in the right form, and this one's not. So I'm going to rearrange it, make it equal 0 first. Collect my like terms, and now I'm not trying to solve, I'm just trying to see if it's solvable. Well, solvable means that I can use my discriminant and do a little calculation here. I've got 64 and 16 is 80. Oh, it's positive, that's important. That means yes, solvable, and actually it has 2 solutions because it has 2 roots, and we know roots are solutions. Now, I don't care what the solutions are. I really don't. I'm not going to try and factor that today. I just want to see if it is solvable. Let's try the next one. Definitely not in the right order, and it's got brackets in there. I need to get rid of that, so let's expand. 4x squared plus 8x minus 3x plus 10. I want to make it equal to 0. I want to put it in standard form, so in the right order. I want to check if it's solvable. So discriminant, b squared, 4ac. Ooh, 25 minus 160, that's definitely negative. Negative 135. That tells me no solutions. It's negative. That means there's no roots. I can't solve this. As I came across this problem, I'd say to myself, oh, can't do it. Stop. No point trying to solve it. And why would I do that? Well, let's take a look at an example. We have a trampoline jumper going up and down, up and down, up and down. And their equation, their height, is modeled by this equation, where t is the time in seconds. How many zeros does this relation have? Well, if I want to know how many zeros something has, it's another way of saying how many roots does it have, how many solutions does it have. That's my discriminant. So b squared minus 4 times a times c. And looking at this, it looks like I can get some positives there. That's kind of good. That's what I want to get. And if I actually do my number, I get 132.8. 8, and what I got there? 8157. Okay, but what's important, the fact this is positive. This has 2 zeros. Now, why does it have 2 zeros? Okay. 1 on the way up, and 1 on the way down. And that would make sense, right? At some point, you're going to be starting on the trampoline, going up in the air, and coming back down to the trampoline. That kind of makes sense. Okay. How many times does the jumper pass through 6 meters? That I don't know. But I know I can put 6 in for my height. And I'll have an equation that possibly, and I say possibly, can be solved. What I want to do is check if it's solvable. So to do that, we have to make it equal to 0. So I need to rearrange this equation, put that 6 on the right side. Oh, it's going to become a minus 6 now. I'm going to collect my like terms, so it's in standard form. Oops, that's a minus now. Minus 4.003. And then I want to see, can I solve this? Because if I can solve it, that means they can hit 6. I took the equation with 6 and I fixed it, right, to make it easier to work with. But that's really what I'm checking. I can check it by doing my discriminant. 9.17 squared minus 4 times negative 6.1 times negative 4.003. Okay, if I put that into my calculator, I get negative 13.58. What's important? That negative sign. No solutions. In other words, they will never reach 6 meters. Now remember, when we're solving these equations, we're trying to figure out the roots. We made the equation easier to work with by going to this idea of 0 right here. But you're actually solving the thing up top. It's hard to solve it when it equals 6. Much easier to figure out when it equals 0. And we've changed the equation so we can make that happen. So our objective today is figuring out how many solutions they have. Discriminant, if it's in standard form, and factor form, just look at, count your zeros. A little bit of problem solving here and there, some questions to try. If you're stuck, come see me, and then tomorrow we'll move on to the big thing, the quadratic formula.